Learning about gears from books is a rather boring endeavor, so today we will experiment and do something interesting. Welcome to the W&M channel. There is a machine tool and there is brass, so there will be chips. You have been writing me about this kind of array for a while, both in the comments and to the email. But back then I didn't have the right machines and skills, so as they say, everything in its time. I am of course interested in making small gears, especially in the context of watches. And such a simple but fascinating mechanism would be just the thing. In some of the previous videos I have already made gears, but in a completely different way. I made them on a lathe, essentially converting it into a slotting machine. It works pretty well, but here is the biggest drawback – the production speed. And of course, due to frequent movements, the wear of the guides. In the meantime, the base of the ring is almost ready. You still need to drill 8 holes at an equal distance from each other. Here, we will attach 8 small gears, using the M1 and M4 screws. Luckily, I have just received this tiny M1, M1.2 and M1.4 thread mills from China. There are taps of this size, but in some cases it is much more convenient to work with the thread mills. For some reason, I didn't find a size smaller than M1 in stores. Perhaps this is due to the complexity of manufacturing, but most likely it's because of how niche the product is and low demand. So, I will have to do everything myself. Now we will cut a fine thread for a thin fixing ring. The main thing here is to accurately center the workpiece, because it is very easy to break a cutter with a diameter less than a millimeter. It is very nice when the mounting threading is the same on different machines. You can safely move the workpiece between them without worrying about messing up the centering. The first part is finished. Its outer diameter is less than 22 millimeters, and thread is so small that it's even difficult to see with the naked eye. Since there will be more parts that interact with it, it is very important to make sure that all the dimensions are correct. Now we need to make 2 identical thin rings. Once the teeth have been cut, this will become side-toothed gears. The inner diameter of the rings will match the outer diameter of the previous part. First, we bore roughly with a large cutter, and then finish the surface with a small one. Then we make an open groove. The ring on the corresponding part will fit right into it. And it's a perfect match. We remove the chamfer and cut the part off of the workpiece. This is more or less how it will all rotate. The most important thing is to make sure the size is correct. And now the hardest part. The reason why we started the whole shebang. We need to make 2 milling cutters for creating fine teeth. First, we make a holder for a broken tooth milling cutter. This is a carbide cutter, and it will be perfect for this job. Since everything is very small, for better accuracy, I will make the markings using the laser machine. Here is the result. Overall it's okay, but I tried to break off the tip, and it broke in the wrong place. So I made 1 more marking, and now we will shape it with a diamond disc. The main thing here is not to rush and not grind off too much from the edge. Considering the small size and the diameter of the workpiece, a little more than 3 millimeters, it turned out more or less okay. This will essentially be a fly cutter. Now we need to make a tool holder for it. We drill a hole in the center and cut a thread in it. We make sure that it's not too long in order to minimize the run out. Then we make a hole for the cutter itself, also with a diameter of about 3 millimeters. This way, we can use exchangeable tool holders and make a large number of exchangeable cutters. Here is how they will be attached, and essentially it is a holder inside another holder. Although we will make the gear small, the design still must be quite rigid in order to accurately fit tooth to tooth. The run out of the cutter is invisible to the naked eye, and this is already good. We make a temporary groove for our workpiece and apply some cyanoacrylate glue. It holds quite well, and if we need to remove the workpiece in the future, we just warm it up. We set the overhang of the cutter to the desired tooth height, and let's go. Here again, a homemade dividing head came in handy. The only thing is that Arduino had to be connected instead of the basic controller. The most important thing is to make sure that the distance between the last tooth and the first tooth is the same as the distance between all the other teeth. And praise Arduino, it worked. Everything is pretty smooth and looks nice. You can take it off and make the second one. Like I said, the most important thing about this method is that the process went much faster. Also, if you buy a microscope and make a micron-sized cutter, you can make very tiny gears. The only problem is that the smaller the cutter, the more errors we get. And with small gears, this simply will not do. Well, we will experiment and see. Now let's make 8 small corresponding gears. Their diameter will be just under 5 mm. We grind the workpiece, leaving a margin for the cutting tool, but still we do not make too long of an overhang, so that it does not bend. After we have polished out the size, we move to the milling machine, and I have prepared a new milling cutter in advance. The principle is the same, the only difference is the number of teeth. A big gear has 60 and a small gear has 12. If you need more gears, most likely you will need to press with a rotating center. In this case, I looked right up close and nothing seems to bend. This means that the size should stay the same. Well, the surface of the grooves, which I was a little worried about, also turned out pretty good. In general, the method is solid. The only thing to do is to get motivated and hone your skills. Why did I replace my old controller with Arduino? Because the number of steps is not always divisible by the required number of teeth, and it could not work with decimals. Now, we connect the controller to the computer, divide 360 degrees by the required number of teeth, and get a nice result. I use free software. It's called GRBL-GRU. We drill through the gears in the center and cut moving the distance of their thickness, 0.7 mm. There turned out to be 10 gears, 2 in reserve. The last part is probably the most difficult one. This will be a ring just 0.8 mm thick, and on the top of that you need to cut the thread in it. We cut the thread with the same cutter, only now it will be on the inside. The more passes we specify, the cleaner the thread will be. I tried the parts, they fit together well, and that means now we can cut it off. Turns out it is very convenient to make different diameter threads with a single tooth cutter. After I cut off the ring, due to its small size it turned out to be not so easy to screw it onto the base. But it worked, and it is good. After that, we can sand on both sides. I already had stainless steel screws. They are M1 and 4, but a little longer than we need. And now we will fix it. Let's make a sample for the required thickness. This way it will be easier to bring them to the same size. We drill 8 holes and cut a thread in each one. Due to the fact that the screws are very small, they cannot be clamped even in a small vise, so I think this will be the best option. Remove a little with the cutter to get the optimum screw size. Now we will screw them all into place and grind. You need to grind very carefully. Brass is softer than stainless steel and can be filed off very quickly. Let's move on to polishing. Brass polishes very well, but unfortunately, the gloss needs to be renewed periodically. We do not polish the base, just sand it. And now we will cover it with this kind finish. It gives us this dark color. It is iridescent and I love it. Thanks to this dark color, we can visually separate the base from the small gears. We polish the small gears last. This is not very simple and not very fast. After that, we wash them from the gooey polishing paste, and they are ready for assembly. First we put on the large gear, then we shift the second one, so the teeth are closer together, and screw the ring on. You know what, it looks pretty good even just like that. Now we move apart the large gears and fix the small ones between them. This is not easy, especially if you have a camera in front of you. First, we turn the screw all the way. Put anaerobic glue on the other side. Turn the screw back and forth several times, and leave it unscrewed by half a turn. That's it, a very nice looking mechanism is ready. This idea is not new, but I wanted to try and do it with my own hands. The screws could have been covered with a plate, but I left them visible for decoration, and I think it looks really pretty this way. Overall, what a job has been done. It worked not on the first try, of course, but the most important thing is that it worked. I hope you, like me, also like all sorts of moving mechanisms, so the world will never stop moving. Bye bye.